Starting off with probability and introduction to probability, we're just going to take a look at some skills that you haven't used maybe in a little while. We want to make sure that we're just on the same page there, and then before we get into our actual probability lessons. So fractions and percents. The term percent means per 100. Cent, cent, 100 cents. Cent being the French for 100, and then like there's 100 pennies or 100 cents in a dollar. That kind of concept. So what we're doing is we're going to be looking at just converting the fractions, a fraction to be out of 100. And when we do that, we're just looking at the numerator portion afterwards. So example, if we have 3/8 as a percent, then what we can do is we can set it up where we want to take 3/8 and we want it to figure out what it is out of 100. Well, all we do is set up this proportion, and then we will multiply the cross multiply the 100 over with a 3/8. So we have 3 divided by 8 times 100, which is 37.5, which is going to be the x value on top of that fraction out of 100. Thus, it's the 37.5%. So the basic process is just that you divide the numerator by the denominator in the fraction and multiply that by 100. Just recalling lowest terms, because we like to work, when we're working with things like fractions and ratios, we like to work with lowest terms. So if we're finding the lowest terms of something, what we're doing is dividing by the largest integer that is a common factor to everything in the fraction or ratio. So in a fraction, it's got to be a common factor to the largest common factor, the greatest common factor to the numerator and denominator. In a ratio, it's the greatest common factor for the 2, 3, 4, or however many terms are in the ratio. So in our example here, we got 6 to 18 to 24. We want to write that in lowest terms. So what we're doing, if we break this right down to step by step, we're looking for the factors of 6, 18, and 24. So these are the factors of 6. We got the factors of 18 here and the factors of 24. And the common factor between all three, the greatest common factor, is 6. Notice they all have a 2, they all have a 1, they all have a 3, but 6 is the greatest common factor. And that's the one we want to select to divide each of those numbers by that. So 6 divided by 6, 18 divided by 6, 24 divided by 6, and that gives us 1 to 3 to 4. And that would be our ratio in lowest terms. Do you have to do all this work here? No. I'm just showing you the full breakdown of it. Normally we would just, if we recognize that 6 was the greatest common factor, we would just do 6 divided by 1, or 6 divided by 6 is 1, 18 divided by 6 is 3, and 24 divided by 6 is 4. Moving on. Fraction arithmetic. So if we're adding or subtracting fractions, what we do is find a common denominator, and then we can add or subtract the top. So when we're doing that, in this case here, we have 1 over 4 plus 3 over 8. So the common denominator in this case, well, we can make 4 into 8 by multiplying it by 2. So if we double 4, we get 8. Thus, that's the common denominator. But whatever you do to the bottom, so since we doubled 4, we have to double the entire fraction in this case. So we multiply 4 by 2, we multiply 1 by 2, and we get to 2. So 1/4 becomes 2/8. Then we just add the top numbers. 2 plus 3 is 5, and we get 5 over 8. Do not add the bottom numbers, just the top. When you're adding and subtracting, add or subtract only the numerators. Note as well that you may have to multiply both the both denominators by something to get a common denominator. If you had a fraction with a base of 3 and a fraction with a base of 4, you would multiply them by each other, 3 by 4 and 4 by 3, to get a common denominator of 12. But you're just multiplying those denominators and only adding the top. Now, in terms of division and multiplication, it's a little bit different. Division becomes multiplication after its initial step. So we'll look at a division question here, but what we're going to do in division is we're going to invert the second fraction and change it to a multiplication question. So in this case, we have 3 over 4 divided by 5 over 8. So what we do is we change that division to a multiplication. We invert the 5 and the 8, and we get 8 over 5. Then, multiplication and division are the same. So what we can do is just straight out multiply 3 by 8 and then 4 by 5 on the bottom and get our fraction that we would have to simplify. I prefer to simplify first. So what we do is we look at a denominator and its opposite numerator. So this pairing here, it's not the 4 and the 3 we're simplifying, but this denominator 4 can be simplified with the 8. They both have a common factor of 4. So if we factor out the 4, we get a 1. If we factor out the 8, we get a 2. The 5 doesn't have a common denominator, and so now we can multiply. 3 times 2 over 1 times 5. 3 times 2 is 6. 1 times 5 is 5. And if you did it the other way and you did 8 times 3 over 4 times 5, what you would have gotten was 24 over 20, which would simplify down to 6 over 5. Ratios and proportions. So we've already kind of shown you some of this just to maybe exemplify what they are. A ratio compares two quantities with the same units. So in the case of a ratio, we're comparing something like if my package of rice says that I mix 2 cups of water to 1 cup of rice when cooking the rice. So it's 2 cups of water to 1. They're both in cups. It's not 2 cups of water to 1 tablespoon or something like that. It's always going to be the same units. So it has, in this case, cups. If I was mixing a larger batch, it could be 2 gallons of water. Then I'm adding the 1 gallon of rice. And that's, again, for the part-to-part of a ratio. So the total number of things, if I was to put this in a pot, this would have to at least hold 3 cups, 2 and the 1. There's also a way to compare ratios called part to whole. And we're comparing the part. So here we're comparing 2 cups of water to 3 cups total. So the mixture is made up of 3 parts and we're using 2. And thus, this setup here allows us to actually set it up as a fraction. And so more often than not, the part to whole ratio will be shown as a fraction instead of with the colon, because it gets confusing. So we usually do fractions if we're comparing the part to the whole, and we're just comparing one part to another. We compare part to part. And we'll see this set up here a little more when we're working with odds. The last bit here for actual math components is proportions. We've already looked at this with setting up something similar with our percentage change from a fraction to percent. But all we're doing again when we're working with proportions, fractions, or ratios, and we want to, what proportions are is just equivalent fractions or ratios. So here, we want to figure out what makes 4 over 9 equal to what over 50. So again, all we're doing is just cross multiplying that 50. In the case where you have something like 1/2 equals 8 over x, something like that, and the x in the variable, the piece you're finding is on the bottom, what you do is that's when you do both sides cross multiplied, and you would have 1 times x, which is x, 2 times 8, which is 16, and then x is 16 there. So if you have x on top, you just have to multiply one piece. If you have x on the bottom, you multiply 2 pieces. And now I found sometimes when I've taught this course that students don't know what a deck of cards actually looks like. We're going to be using decks of cards as a common measure of probability and combinatorics later on. So a standard deck of cards has 52 cards in it. We do not include jokers or any of the extra little cards that come. Jokers are there as spare cards or for playing specialty games, but a standard deck of cards, and if it's not specified as something different, you assume it's a 52 card deck. Half the deck will be red cards, half will be black. The red cards are hearts and diamonds, so there's a quarter of the deck is hearts, a quarter is diamonds. The black cards are spades and clubs. A quarter of the deck is clubs, a quarter of the deck is spades. That means 13 there's 26 red, 26 black. There's 13 hearts, 13 diamonds, 13 spades, 13 clubs. Hearts, diamonds, and clubs are called the suits. Each suit has the 13 cards, which are the ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. The jack, queen, and king are known as face cards because they have a face on them. Also, when we're talking about dice, one singular is called a die. So if you have a singular a pair of dice, then you have a die. So a die is one, and then dice is more than one. A standard die, so if we're talking about rolling dice in that, we assume, unless told otherwise, that there are 6 sides on the dice with the numbers 1, 2, 3, 4, 5, and 6 on them. So set those to memory because they will become useful throughout our different problems in this course.